All right, folks, I want to give you a demo on how you can use millis and timers to um, functionally make delays in your code without blocking it. So one of the things you may have noticed is if you use delays, the processor literally stops and waits for the delay time to pass before moving on to the next line of code. And if you are expecting or waiting for user input like a button press, that can be really problematic because if the button press happens during the delay, it'll get lost and never acknowledged. So if we wanted to make something that has, for instance, one blinking LED, and when you press the button, light turns on, and when you release, it goes off, and that blinking and the button pressing work seemingly independently of each other, right? So I'm not using delays to blink this one blue. So let's look at a way to do that. I'm using the circuit playground, so I've got my library in here. I only need a couple variables. I've got a long called timer that's going to start equal to 0. So that's going to be my timer for the sketch. A long is like an integer, but that has even more memory space. So it can go much higher. When we start working with time, especially intervals, if we're going to have an installation or something that's going to run for days and days, this matters. If it's not going to run for a very long time, it matters less. But just to be safe, we're going to use a long for our timer. I've got a constant integer called interval, which is 1,000. That is my blink speed here. So the blue light is blinking every 1,000 milliseconds. That's like the delay value. Okay, so the interval is the delay value. And then I've got a boolean called toggle, which is just going to be true or false. In my setup, very basic stuff you should be familiar with. I'm setting pin 13 to output. Actually, I'm not even using that anymore. I don't need it. Pin 4 is one of my buttons. I'm setting that as a pull down. As an input, starting serial, starting the library, waiting a second for those things to initialize. Okay, then in the loop, again, this is very basic. I'm reading pin 4. If it's pressed, it's going to set pixel 9 to red. If it's not pressed, it's going to turn pixel 9 off. That is my button. Oh god. There we go. The button. All right. I could throw in a little debounce there, right, if I wanted to. And I could do that with a delay. If it's very short, it's not going to matter too much. The delays become problematic when they're more than 100 milliseconds. They become very noticeable. So that's what we want to avoid. So how do I do that, right? So we've seen with the blink, I can do that with a for loop. But a for loop with a delay in it is going to lock my code. So I'm going to not do that. I'm going to use this function called Millis instead. So Millis is a built-in function that returns the number of milliseconds that have elapsed since we turned the circuit playground on. So it's kind of like a clock, but it doesn't know what time it is. It just knows how long the circuit playground's been running. And so my check is if Millis is greater than my timer plus my interval, I'm going to do stuff. And when that is true, I'm going to reset my timer to equal Millis. So let's just play that through. So initially, my timer is 0, my interval is 1,000, so it's going to check is Millis greater than 1,000. So when I first turn on my code and run, Millis is 0, then 1, then 2, then 3, then 4. It's always less than 1,000 for the first second, up until Millis equals 1,001. So until Millis equals 1,001, this doesn't happen at all. Then if it does, when it gets to 1,001, that is greater, it's going to do the stuff, and then it's going to set the timer to equal to Millis. And so the timer will equal 1,001, maybe 1,002, depending on how quickly it's running. And then we're going to come back, All right, so is millis greater than 1002 plus our interval, which is 1000, so 2002? No, millis is probably 1003, 1004, something like that. So again, it's going to wait and wait and wait until millis equals 2003, and then it will do the stuff again, reset the timer, etc. So that's how we, without blocking this from happening, can wait every second to do stuff. For the stuff that I'm going to do, I'm doing very simple toggling, like from our first project. I'm just checking if toggle is true, make NeoPixel 5 blue, set toggle to false, and print on. Otherwise, set pixel 5 to off, set toggle to true, and then set the LED, or just print LED off. So just to be clear, right? So if toggle is true, we're going to do something and then set toggle to false. So the next time through, toggle is false, it's going to do something else and set toggle to true. So when we're using toggles, or sometimes you'll hear them referred to as flags, right? We always have to set those back and forth opposite of what we're checking. And so that's how we get this, right? So when I push this, I get red or not from here, and then here every second it's toggling that LED on or off. So that's how we can use millis to put delays into our code that don't block other functionality.